Okay, here we are in lesson 11, video 2, and this is number 1 in your book, and it says find the area of the rectangle. And what do we notice about this rectangle? Make sure you're taking notes in your book. Do you notice that the side lengths are both fractions? That's to be expected. We're studying that this lesson. And the fractions are both greater than 1. Right? Remember that if the numerator, the top number, is bigger than the denominator, then it's greater than 1. That's when we would switch it into a mixed number, right? So like 6/5 would be equal to 1 1/5 because we see that a 5 fits into 6 one time, right? And there's going to be 1 left over. So that would be 1 1/5, and 3/2 would be 1 1/2, right? Because 2/2 would be the same as 1 with 1 left over. So those numbers are bigger than 1. What size tiles could we use to tile this rectangle? What do you think? We've been talking about our tiles and how many tiles we need. Since these are fifths and these are halves, I'm thinking that our tiles could be 1/5 by 1/2. Right? 1/2 on this side and 1/5 on this side as we're making those little tiles. You might want to think of this as like a bathroom floor, something like that. Maybe even an art project, right? So what size tiles do we need to fit inside of there? And if it's 1/5 and 1/2, I'm thinking about 1/10, right? So let's go ahead and try and draw it. So here's our 1/2, half and half. And then here's our fifths. 4 lines makes fifths, right? And they don't have to be perfect. They're not going to be perfect. Okay. And so we have fifths on this side and halves on this side. And what's the area of this one tile? 1/5 times 1/2. Are you thinking it's going to be 1/10? Yes. So the area of that small tile is going to be 1/10 square units, right? So I'm just going to put square units there so that we remember that our area is always square because it's covering this whole section, right? It's not a straight line. How can we use what we know about the area of each tile to find the area of the rectangle? So if this one is 1/10, the area of the whole rectangle isn't 1/10, is it? How many boxes do we have? Oh, did you see my mistake? This is 6/5, right? So we need another fifth, right? It's more than 1. We talked about that. And this is 3/2, so we need another half. Glad you caught that mistake. There we go. And now we have 1, 2, 3, 4, 5, 6 here. 6 times 3 is 18. So there's 18 parts, and each one is 1/10. So that's going to be 1/10 times 18, or 18/10 units, square units, would be the area of this whole thing, which is the same as 1 10/10 with 8 left over, 1 8/10 units squared. All right, starting to see it? Okay, let's just check out some more squares here and see what we think. Sorry, rectangles, and see what we think of these. We can find the area of a rectangle tile with unit fraction side lengths. Remember, a unit fraction has a 1 on the top, right? Unit fraction side length by multiplying the length and the width. I wonder whether this is true for any rectangle with fraction side lengths. What do you think about it? Okay, here we have 3 rectangles. 1/3 by 2/3, 2/3 by 3/4, 6/5 by 3/2. So we have a variety, and I've written them all here in my chart, and let's double check I have the lengths and the widths, so 2/3, 1/3, 3/4, 2/3, 3/2, 6/5. Okay, and I need to find the area for those. So we said we were going to see if we could multiply, right? We previously found the area for all of these rectangles by tiling, but let's try by multiplying. So length times width equals area, right? Length times width equals area. Length times width equals area. So that would be multiplying straight across. 2 times 1 is 2. 3 times 3 is 9. 3 times 2 is 6. 3 times 4 is 12. 3 times 6 is 18. 2 times 5 is 10. All right. Looks pretty good. I don't think I made any mistakes there. What do you notice about the denominators on the length, widths, and areas? The denominators down, the bottom, right? Yes, do you notice that it's a product, right? So 3 times 3 is 9, 3 times 4 is 12, 2 times 5 is 10, right? We just did that, so that kind of makes sense. What does the relationship tell us about the size of the tiles we can use to tile the rectangle? Let's use one of the rectangles represented in the table to explain our thinking. Okay. So if we have 1/3 and 2/3 here, then that would be 1/3. Think about the rest of the unit square, right? And then this is 2/3. Thinking about the rest of the unit square, just ignore that part there. Okay, so you see how I drew my whole unit squared, and I used 1/3, and I used 1/3 here. So my 1 square is 1/3 times 1/3, 1/9. Does that make sense? Because I have 9 sections, and one of them is 1/9, but 2 of them is what I need, and 2 of them is 2/9. That matches up. Do you remember these from when we did these before? And the numerators. The numerators are also multiplication problems, so the area of our numerators are products of our numerators. That makes sense. Can we find the area of a rectangle with fraction side lengths by multiplying the side lengths? Are we saying this for sure? Have we proven it? Yes, I think we have. How is finding the area of a rectangle with fraction side lengths like finding the area of a rectangle with whole number side lengths? Multiplying length times width equals area. It's the same, right? We have the formula length times width equals area. And if you don't know that for whole numbers, well, you should know it, because if my length is, say, 5 and my width is, say, 3, then my area would be 15. And I'll just say units squared, could be meters squared, could be feet squared, anything like that. Okay, very good. And I'm going to see you for video 3, and we're going to be talking about numbers 2 through 5, where we're doing a chart very much like this. So I'll see you there. Thank you for all your hard work. Great job.